All right. Welcome, everyone and anyone, to week 11 of the Arc Academy for Qlik. Today, we're going to be covering the first series, weeks 1 through 10. It's primarily based on beginner intro to Qlik, understanding how the tool works, understanding how to use it. Now that we're covering this next segment, weeks 11 through 20, we're going to try to do more intermediate to advanced topics, keep the progression going here. So kind of getting into this phase here now. So we've talked about the intro to data modeling. Now today we're really going to talk about the strategy. When to do data modeling, best practices, when it doesn't matter. You know, maybe it matters based on the tool you're using for something like on-prem, something like Qlik Cloud. Maybe your package is a little different, right? So let's talk about the strategy here behind data modeling, some of the math. Couple things here. So the first thing we're going to dive into, we talked about this, is just kind of a review here from the intro, is the concept. When we talk about data modeling in Qlik, it's not about jamming everything into one table. We can see here in option 3, that can be bad for RAM. That can be bad for really, really high cardinality apps, really wide tables, a lot of different users, things like that. Really tall, wide tables, big transactional tables. It's also not good to just do this huge nested snowflake, depending on the size of these tables. Again, star schema seems to fit most things. So again, why the engine, why the associations are powerful. Typically this is what you'd see in a view, and then this is what you'd see in huge package reports. So no one likes using views, and no one also likes using things like stored procedures that have 100 nested subqueries inside of them, and then they only return one record or one thing. So that's kind of the power here. Understanding why associations are important. You should already kind of be here. If you're not, I would say focus back to data modeling. This is more kind of in the weeds of that. We're going to talk about some consumption thresholds after this. But again, understanding why we're preferring to use the star schema versus flat tables, when it makes sense, especially in your data model. You can join the order of operations of how you load tables should not be random. There's a strategy behind when you join a thing in versus when you join a value in to drop the values out. The more that you're pushing through the whole load, the more you're going to consume, whether it's on your server or on Qlik's server. And then the goal here is to stop building Excel-style data models. And I think what we mean by that is, everybody kind of knows someone where you have a simple version of it, where you have like 2 tables, 2 worksheets that you're just constantly going back to. They're your master Excel workbooks, and you're just kind of referencing this crazy VLOOKUPs going on between back and forth. Or you have the person that treats Excel like it's an Access database. Huge liability there between like just data entry, number formatting, all kinds of things, reference links breaking. Someone the other day just told me that, they got their budget mixed up because of a reference in Excel. So we don't want that kind of stuff to happen. So moving on, this is an important concept, and I found this slide because it's really important to understanding how Qlik's in-memory engine is going to work here, especially work with your larger data models. So if you look at this table, the whole point here is to show the effect that RAM has on adding more data. And when you add these records, these are really just records of cardinality. It doesn't mean that once you hit 1,000 records, data model goes down the drain. It means once you hit 1,000 records, the way to kind of read this is that anything over 1,000 records really behaves the same up to, I've seen hundreds of millions of records in transactional tables that are cross-table and things like that. What Qlik is looking for is the number of unique index keys. It's very focused on building a key relation to each pair. It's really replacing ones and zeros in there. So if you think about a good example that I like to think about that I explained this is a timestamp. If you take for a 1 calendar year from January 1st to December 31st, if you take all 365 days and you just take the date there, you only have 365 values. That's a very short table. It's a very manageable table. If you now have that column in a if that's now a timestamp that you're doing for a year, think about every possible second that exists within a year times 365 days. It's a lot because you have 86,000 seconds in a day times 365. That table gets exponentially larger. So it's not to say that you shouldn't use timestamps. It's to say that you should, categorically structure your data where create a timestamp value table and then you have your daily value table. So if you're just structuring out timestamps and then you have a bridge, you have them linked. So that way each day has the timestamps placed in the bridge. And just separating those two, again, you're giving Qlik, that's an example where you're giving Qlik less cardinality to deal with, because it's instead of recognizing each one of those 100,000 records as different, it's now just doing it through a link table. It's much more efficient. So this is kind of a cool little curve here to see, and you can kind of see where things do well between the matrix. And really all that you're trying to focus on here, these graphs down on the bottom really just focus on number of users. But as you ramp up number of users, it's RAM based, but as you ramp this up, it's really just how steep do you want your curve to be, right? Do you want your curve to shoot up immediately and then taper off, or this is more the taper, or do you want it to kind of have minimal growth after that? It's really how fast do you want to plateau. But it's all about symbol tables, and that's important to think about when you're working with large data structures. Again, if this is something where your organization is using Excel tables or, simple like hand punch database, these are monthly values, this stuff does not matter. This stuff matters when you're dealing with tens of thousands of hundreds of thousands of millions of records, and you're trying to do a table with 10 million records of transactional claims. You have 2 or 3 hops over to another table of providers, and then you have 2 or 3 hops over to a mapping table with geo points of where the providers are on a map. That's the kind of situation we're talking about here. And then say 100 people need to access it, right? That's where you start adding some server load. All right, this is more of what I meant about the user activity on data modeling. So that's really how the last slide talked about how the data model is going to handle more RAM, consume more RAM with not just an incremental amount more data. Once you hit that plateau, you're using very small amounts of data. The same concept kind of goes here, is that once you really hit your working set, you can see here we have the memory allocation. This is your RAM now on the left side. And then over time, think about this user activity, this session duration. So you can kind of see this gray bar is what's always going to be on the server. It's always there. That's just the base QVF file, the hard packed in, the data model is not expanded, no key values are loaded. Well, what you start seeing here is when sessions start opening, you have more of this cached data flowing in the data model, and that's where it becomes available. And kind of the same concept here. The RAM increases as the user in session increases. There's a delay. So even though sessions spike, you still start unpacking data as they make selections, they navigate, do whatever. And then you plateau, the user session ends, and then you start to taper off as people start to close out sessions, data models compress, it starts to package it all up. And then now you don't have any more session activity, you just have the cached data. And then depending on how you have your Qlik server set up, that cached data will sit out there. But now that cached data is there, your RAM is being used, but you don't have to reload that data anymore. That data is sitting there for the next person to come in nice and speedy, nice and snappy, ready to go. So really important to understand how these data models work. If you have, say your app is going to be this huge app, it's, over a gig of data that you're loading into this thing and modeling it out, making all these link tables. It's important to understand that it's not always the best use case. Just because you can do it doesn't mean you should do it. I can go take my truck to go get groceries. It will get me there. Doesn't mean it's the best vehicle to go take and go get groceries. It's much better suited for something that I need to go to Home Depot for or pick something up. So again, knowing where to draw that line in the data model and knowing where to split things up, very, very important. Moving on. To kind of close out that thought here in the last slide for today is kind of highlighting that idea, knowing where to draw the line. And then what I want to come back to is, again, these are kind of two different graphics. So, kind of bear with me here. But on the left side, working from left to right, this is really where the enterprise or organization is going to start. You're going to have your data warehouse or your databases, your on-prem stuff, files floating around, Excel, text, CSVs, whatever, any type of systems, maybe APIs. Well, how you pull these things in and the tools that you use to hop through them are entirely up to you as a developer. And this is where you get to decide how to slice that data model. This is an example where if you were to touch all of these steps and end up in the analytics platform, this is a pretty large build out to have a DI process, to be doing data lake stuff, doing stuff with your icebergs. You have change data capture going on with live streaming. Then you have it landing at a consolidation layer. Then you have catalogs and data products, then moving into visuals. This is a full built out enterprise, medallion status, everything end to end. This is huge. And this is not where enterprises start immediately. It takes a lot of time to get here. And just like this diagram on the right, that's why I have this here, is it all starts with, where you're at now. Some people, you can do all of this inside Qlik on-prem. You can do this all really in Excel, depending on the size of your project. If you just take out this file portion, you can kind of imagine this portion going away. You don't need QDI to pull in Excel files. You really don't need a database, so you can have an Excel file go into kind of like a data catalog, call it a Qlik, call it a QVD file. You have your QVD library, and then your QVD libraries can run your apps. And plenty of people do that. And that's a much better structure of starting that process. And that's what this data quality process is it's starting, get your requirements, assess it, validate it, clean it, govern it, and control to report on it. So any direction that you take this process, it can be as simple as file to QVD to app, it can be file to app. There's no right or wrong way. Doing something like this is great, but not everybody can do this. Not everybody can afford it. Not everybody has the resources on hand to do this. So that's the importance here today, is understanding that your DQ process can fit anywhere in this diagram. And all that matters is figuring out where you choose to insert it. I've worked on projects where you can put it in every place. You physically can do a DQ process inside of here, DQ process in this area, DQ process as it goes into the catalog, or some of the stuff already exists. So you only need to add it in one place or the last checkbox, but just understanding that one individual idea of this process isn't going to fix everything. It's always a stepping stone. It's always evolving. And, while you're using, say you are using the Excel files to QVD library now, eventually they'll go Excel files to data warehouse to QVD, or they'll go Excel files to change data capture to data warehouse to QVD. So you can really get creative with this, and that's the point here. The last thing I'll touch on here actually a little bit is with cost. Coming back to that, the cost of something like this again, it depends on where you want to put your DQ process. If you want to put DQ in every step of the way here, not only do you have to have the tooling and manpower to do it, you have to be able to have the checks and balances behind it. I think everyone thinks it's a great idea to have a DQ process in 5 different places, but when you really think about having a team validate that, having a team do the assurance, and then having this governance all the way through and documentation, every time you add this into somewhere, you're giving that team a full-time job. So you have to think about where you govern those, where you want those gates. When you think about it as gates, data gets a lot of analogies to water because it flows. And I think when you think about it as floodgates trickling down, you're really going to get charged on where the gates are. And that's with anything. If it's with on-prem, you're going to be getting charged in terms of your server usage and your human capital, your contractors. If it's with Qlik Cloud, cloud hosted services, not even Qlik, any tool that's cloud hosted or virtually hosted, VPS, you're paying for it at the gates, paying for the hosting, and you're paying for the licensing, paying every time you run through this process. And Qlik is nice in the sense that each one of these silos, one of the colored boxes, now they represent individual Qlik products. But you can do all of these things just inside Qlik Cloud. So even just purchasing standard tier of Qlik Cloud, you can do automation. You can do a little bit of it, can't do a ton of it. You're not going to do CDC until you get to Talons, but that's part of the larger picture here. You can do data warehousing. You can do data catalogs. You can do data products. And then obviously you build apps. So what's nice is all of these things come under the hood as your starting point in something like the cloud. Then as you get the opportunity to grow that out and really expand on building this out and taking on that step, you can split these out into what they're meant for. And you're not kind of reinventing the wheel there. So that's the last thing I wanted to mention here is that think about this when you're developing your entire data strategy, not just the data model. A data model is really representation of what you plan on doing with your data as a whole, of what your whole data strategy is. If your data model, if you have an application, you have a Qlik app, and your data model's job is to all in one load script, go in, make a QVD loader, that same chunk goes right down, it cleans the data, it profiles it, it splits it out, it trims it, it does mapping tables, slices it. Say the thing takes 20 minutes to run, partitions all these tables, stores off other QVDs, and then loads into one app. If that's all happening in one Qlik app, there's a world where that's okay. But that's where it's really time to take the next step. If you're relying on one load script to do all of that work, and it's very fragile, you can't tell where things are breaking along the way, you have to go back through the logs, and you're looking at these things, that's where it's time to start saying, hey, let's get some automation behind these tasks. Let's split things out into a QVD script and an app script. Let's split out the QVDs into layers of cleaned and transformed and calculated, or the medallions. And then let's package them into products. Products is a new feature in Qlik Cloud, data products, which is nice. So that's really how you can think about these boxes. As you start to overload one box, it's just like anything else. Back to my grocery store. Going to the grocery store is fine in the truck until I'm buying food for a restaurant. If I'm going to that grocery store, if I'm going to Harris Teeter, I'm bringing my truck, it's fine if it's just my trip. If I'm trying to buy it for Buffalo Wild Wings, yeah, I probably need to call Cisco. I probably need to get a data integration tool in place to help me pick up all the chicken wings and all the sauces and everything. That's not all going to fit in my truck. it was great for the size of the company. So it's important to understand that as data flows, as water moves, as these things go through a pipeline, it's just like anything else. You have to have the right tool for the right job. Today's session is a little bit shorter. I don't have Austin with me, so I'm not going to do a technical deep dive. And that's really what the point of the diagrams is today, is to talk about the strategy. That's really what this next couple of videos are going to be about, is the strategy series here, understanding why we do the things that we do. So now that you've got an intro to data modeling, you understand, okay, how to link tables, auto number on this value, auto number on this value, link them together. Now we're starting to talk about why you need to do the things that work in scale, in production, in security, and in real-time application. So that's today's session on data strategy. Or data modeling strategy. First part of the strategy series here for the intermediates. And we'll see you next week. Thanks.